Okay, we've already downloaded the Desmos app. If you're watching at home, it's a free app. You want to get that on your phone. We're going to use it a lot in class, okay? So get the Desmos app. It's free. It does not use Wi-Fi or data. So it's a standalone in your phone, and it works just like a graphic calculator. It actually does more than a TI-84 does. You can do some things with it that are kind of fancy. There's some great things to it. We'll find our way through all of them. Looking at this, what we're going to do is graph quads with different forms. So we have our 3 different forms over here. We have our 3 different forms. And we've already tested on going between the forms. All right. So you don't have to copy this down, but you see the parts that you could find from each form. It's really easy to find the X Intercepts because it is the P and the Q value here. You can always find if it's facing up or down in each of them because they all have an A value. And that denotes the same function. The vertex, if it's in vertex form, it's just H and K. We're going to have to pay attention to the sign, and when we get to labeling that, we'll just be really careful about this. The X of symmetry is just X is equal to whatever H is, which is nice, and then up and down. Standard, we knew we can find the y-intercept because we plug in 0 for X, that's where we have the y-intercept, and that's C left over, so it's equal to C. X of symmetry, a little hard to find it this way. And once you find the axis of symmetry, you plug it into the equation, and that's going to allow you to find the y value for it. So that's all we need to know about it, about quads. We could find in the different forms. So let's look at this. Really, today is about defining, and I want to get you guys used to using Desmos. Okay, I think that pulled it over. So let's look at this problem. I did not even put the y-axis on this situation because I do not care about the y variables. All I care about is what's going on with my x values, right? With an interval of where it is increasing, where the function's increasing, and where it's decreasing. So just remember, it's increasing when you're going uphill. We always read from left to right, just like we write out polynomials left to right. So from left to right, you know, this keeps going down forever, so we're coming up the hill, you know, from negative infinity coming this direction, and it's increasing. So it's like the roller coaster where it's like, it's pulling you up slowly. When you get to the very top, is it increasing or decreasing? What do you think? What's happening right at the very top? Instantaneously, yes.
Well, instantaneously gathered as potential energy.
Ooh. We went way into physics that time. Yeah, you know, there's aspects of, you know, the energy potential is, you know, gravity is going to pull us down. It's the weight of the cars. What do you think, Tian? It's neutral for a moment. Right between where you are increasing, right, to where you're decreasing. If we're denoting increasing by having a positive slope between 2 points, positive. It's a positive. It's a positive. It's getting narrow, though. And when we get to the top, the slope at that point is 0. When you learn calculus, you take the derivative of your function and you find the slope at a particular point. You find the rate of change at a particular point. It's an interesting. You can do this. It's interesting. I see some nods. You know how to do it a bit. Okay, that's where calculus comes in. You could find almost like secret information by taking the derivative. I'll leave it at that bad explanation. I'll keep moving. Once we get past this inflection point, what happens? Decreasing. And it decreases as it goes over to the right. So way over here at positive infinity, it's still decreasing. You guys get that? Because it's not just going down, it's going over to the right. Down, 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 forever. So now if you had to tell me what interval, what segments of my x values it's increasing, what would you say? Think about it. Tell your neighbor what you'd say. What interval for my x values, from left to right, is this function increasing? Tell your neighbor. Tell your neighbor. Where is it increasing? All right, am I calling somebody? Let's call on. Let's see. Which one? let's see. How about Tyler? Can you help me out? What'd you guys say?
We said that might be increasing from negative infinity
Good.
to like maybe x.
Okay, this is perfect. Till x, and who can finish that up? I like this. So you basically have, your lower edge is negative infinity. Now, where does it stop increasing, though? Where does it stop increasing? 10. Oh, 5. You did it symbols. So are you sure? Let's see. It's increasing, it's increasing, it's increasing. Right when we get to x is equal to 5, it levels out. So I'm not going to include 5. I'm not going to do a hard bracket like that to say 5 is included. Is 5 included? No, because at 5, what's happening? It levels out. There is no increasing or decreasing. So I need to write this like this. This is exactly the same as if we did, let's see. It's increasing, increases from negative infinity is less than x is less than 5. You can also put it in as an inequality if you want. Or function notation, interval notation. This isn't x and y. This is saying what x values is the function increasing. It's increasing from negative infinity. This direction is negative infinity. Way over there. Comes up. Right at 5. It stops increasing. Yeah? Thumbs up, sideways, down for that. Yeah. Feel like some are still here. That's fine. Tell your neighbor, when is it decreasing? When is it decreasing? Who should I call on? I'll take a volunteer for a Starburst. Help me out. When is it decreasing? When in the back? Yep. Perfect. Good. Do we include 5 in that? Do we include 5? At 5, what's happening? Flattened out. It's neither increasing or decreasing. It's an instantaneous point. These are, infinite points, and then there's one point where it's flat. Then it goes back down. It's almost like instantaneous. You cross that point. So watch. I'm going to go ahead and say 5, positive infinity, not x and y. This is essentially it's looking at what domain is this decreasing, what domain is this increasing. Looking at the x values only. Okay. I don't totally trust everybody has it, so I'm going to go do this. Let's go x is equal to negative 3. X is equal to 5. And let's say we have this function going on. That's an ugly function. It could be a shifted sine curve. It could be just a polynomial, like a 6th power. All right, so let's look at this. I want you to tell your neighbor under what intervals of x, between what segments of x are we increasing? We'll start with that. From where to where is it increasing? From where to where is it increasing? Good, talking. Keep talking. All right, good. Okay, Matthew, help me out. Can you give me one interval where it's increasing? Well, how about answer this question? What's going on over on this side? We read from left to right. Am I walking uphill or downhill? Is my roller coaster going to the top or falling down? It's going up, right? So it's increasing over here. This domain is increasing over on this side between negative infinity and negative 3. It's increasing all right here. Increasing, 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 and then we stop. Okay. Now, I see some people are still in their mind thinking about the y variables. Well, am I asked about what's happening with the y values? No. All we're looking at is what x segment, right? What x interval is it increasing? It's from here all the way over. It's coming up. It's coming up. It's coming up. Then it starts to go down. Somebody else give me another increasing interval. Who else has one? Paloma. 5 to infinity. You see it? Domain is increasing. 5 to positive infinity. Yeah. Angie.
When you're only given like that section, do you just assume that it's not going to curve again and then it's going to go all the way down?
Yes. In behavior, we call it in behavior, and it is consistent and continuous. So this would keep on going. There's not going to be another little tweak in there. Yeah. No tricks like that. Under what interval is it decreasing? Under what interval is it decreasing? I'm going to do that one in black. Angie, help me out. Between 3 and 5, it's decreasing. Luckily not right here, so I'd say the domain is decreasing between -3 and 5. You see, we're just taking the intervals. Here, basically, it's all decreasing. Okay? Because it's going down. The function's actually going downward. From left to right, we always read. Yeah?
Can we think of it as for domain, both values
Repeat the last sentence again.
both values, so we're talking about the domain, it's just going to be x.
Correct. This is good. If I wrote this out in a sentence, I'd say the function is increasing for x values between -infinity all the way to 3. Or to the values less than 3. -3. Okay, so we got, let's see, we have increasing on this side of the graph. We've got some increasing over here, decreasing in the middle. Okay? Good. Thumbs up's always down. Okay. I think if anyone is sideways, it has to do with what are we looking at again? Because I think about it, and this is a function. This has an x and y value, but really just remember that we're just looking at the segments, right? Where it's increasing, and then it starts to decrease between -3 and 5. And then from 5 on, it's just increasing. Okay? That's it. If you really get it, perfect. If you don't quite get it, you'll have some practice with it. Okay. Whew. All right, so that's what we did right here. For what x values is the function increasing and decreasing? We went ahead and put it here. So we can now look at this. All right. Whoa. Oh, I have another VGA that I can use. I'll use it next time. All right, this is what we're going to start on. We're going to fill these in from the equations I have up here on Desmos. But the basics of this, evens are symmetry, SYM, is across the y-axis. And you can see here, if I plug in negative x values for the function, and I plug in positive x values for the function, we get the same answer. And we're going to see what happens. Think of our parabola, right? So if I put in the negative x value and the positive x value, I'm still at the same f of x value. I'm at even because it's the same distance from that center line. Now, if that was the y-axis, we would have symmetry across the y-axis. How about this one? Odd. Odd, we have symmetry. Symmetry around the origin. Here's the origin. We have symmetry around that. So we have either symmetry here along the y-axis or around the origin. Okay. You're going to see what kind of function makes that possible. Neither, it's neither this nor that. Okay. So I'm going to go and put like an example of a neither function. That would be like that. Is that symmetric across the y-axis if I folded that paper in half? Not even close. Is it like the same up in this quadrant as it is down here? No, there's no symmetry at all. That's a neither function. Okay. So you're basically just looking, is it symmetric across the y-axis? Is it across the origin? If not, to either, then it's neither. All right, let's see what we got. I reject that idea. All right, we're going to just go ahead and graph some of these real quick. So go ahead and get back going with Desmos. I think I'm going to close this. We've been in such deep topics where you had to do a lot of computation. Everything here that we're doing is pretty much, you can graph it using Desmos and pull out the information. Okay. So, oh yeah, we got to do this example problem too. That's no problem. All right, so let's look at the graphs. I'm going to go ahead and get it so it is readable. All right, folks, tell me what you think about this function. Tell your partner, what do you think about that function right there? Tell your partner, which one of those does it fit? Let me zoom in for people at home. There we go. It's kind of visible. It's a little dark. Okay, so right now we were doing, it's hard to see. Hello. That's the best I can do. Okay, let's see. Jack, what do you think? Which one of them does it fit into?
I would say odd.
The what?
I'd say odd.
Odd function. Good. If you look here and you see, watch. Here's almost like a propeller on a plane, right? Symmetric around the origin. Is it the same shape if I rotated it over there? It is, right? That's odd. You're going to graph these functions for the homework. You're going to graph them using Desmos. That's going to be one thing you're going to have to observe. Say if it's odd, even, or neither. Yes?
So like when it's supposed to rotate around the origin, not like flip around it, right? Because if it flipped it would go the other way.
That's correct. So it's a direct rotational translation. It's not a horizontal rotation or flip. It's not a flip. It's not a flip the vertical rotation. So it is rotating around the origin. It's the one weird one. Yeah. You guys did transformations before, I think, where this moves over here. Okay, that's math 1. Okay, I'll teach that later for my math 1 kids. All right, how about this one? I'm going to leave that up compared to this. So if you have on your phone, you might just turn that one on. You can turn them on and off from the button over here. You can change the color if you want to be fancy. You hold it with your finger, and you can change the color. Yeah. Oh, now you guys like it. Ooh. Change it to pastels. Yeah. Anna.
So how do you create the powers for each expert? How do you create the powers like that?
Create the powers?
Yeah.
How do you input it?
Yeah.
Okay. So if I had to input it, I'd pull up I have it zoomed out. Get it up. So you pull up the keyboard, and then I would go, okay, X raised to the a to the b, raised to the 7th power. See? Right? And then you have to move over, I think, yeah, and then you could do plus 2, X raised to the 6th power. Look at that function. Is that black function right there odd or even? Or? Neither. Obviously neither, right? Fold the y-axis, no. Rotate it, nothing's going to happen. How about this one? This is the one we were doing. I think it's the green one. Let's turn off the others. Neither. Pretty easy to see it. Honestly, I took a long time describing it, but if you can recognize it from the graph, we're going to use technology for this. It's permitted. So I only have one other thing to teach, and it's been back and forth. Sorry about that. Tien?
What part of each function is considered even, odd, and even?
Each function is going to be classified as one of those. So one function will never be more than one option. One function either fits in even, or it fits in odd, or it fits in neither. It's a either or statement, not a both and.
But which
Right. So here's the deal. We had up here y is equal to x squared. This is a parent function, right? This is a parent function of a parabola. It is even, right? What happens though when I do this? Let's see, I'm going to go ahead and make it parenthesis, and I'm going to change this to plus 3. Is it even still? Is it symmetric across the y-axis right here? If I folded this along my y-axis, would it be exactly the same on both sides? No, because the center of it has been shifted over, right? So even a quadratic, which is to the second power, is not necessarily even or odd. So it's tricky. You'll start to see it in Math 3, where you can make some more inferences about it. But right now, we're going to graphic spot it. Okay. Or you can plug in a negative x value for the function and see if you end up with the straight original function. If you plug in a negative x, change out the signs, and you get the same place you started, then it's even. It's one other algebraic looking into. Question? Anybody had a question? Touch it. This right here? This is neither. Why is it neither, guys? Anybody help explain that a little bit? Yeah. Or why? Yeah, we shift that thing over, it would be a different function, and we could make it into an either. But this function as it is, x plus 3 squared, is not an even function. Ian? Then it's a relation, it's not a function, so it is not classified any different. It would be, I guess if they're turned sideways, it's neither for all of them. We don't turn our parabola sideways for a while. So I don't remember actually teaching that, so I can't answer that. But as far as even, odd, or neither, it is one of these options. And it is, so if you had that, you had a parabola sideways, it'd be neither. It doesn't have any symmetry around the origin or the y-axis. All right. Last thing, this problem right here. All right, so this is what we're told. We have the y-intercepts are at 1 and 5. 1, 2, 3, 4, 5. 1 and 5. The parabola is going to go through those 2 points. Okay. Now, if we have a minimum of negative 10, down here at negative 10, that's where the floor, the bottom, the minimum is going to be for my parabola. So does this one open up or down? If this is the minimum for the parabola, and it goes through these two x-axis intercepts, these x-intercepts, if that's the minimum, then I know it opens like this. Okay. The x-intercepts is just where it crosses the x-axis. Now, this type of problem we're going to have in the workbook when you guys get to that problem, and it's going to say, what is the value of x that minimizes or maximizes the function? So where is our line of symmetry in this problem? We know that this vertex right here, right, is going to have some x value and negative 10 in there. Because the minimum is negative 10, that must be the y value for it. But what is this? Jack?
Axis of symmetry.
Axis of symmetry. And at what x value is it? X is equal to? 3. You could visualize that, right? Remember that from the axis of symmetry, if we go either direction, it's the same distance to get to the function. Same distance, same distance, same distance, same distance. Because it's symmetric across that. So it's the same distance on both sides. Okay? So thinking about that, I know I'm at 1 and I'm at 5. How do I find the number in between 1 and 5? Essentially, what are you finding? Dan? The mean. You said the mean? I thought you said medium. Yes, the mean. You're finding the average in between them. If I have 1 and I have 5, add them together. 6, divide by 2. Okay, 3. Now, what happens when we have one like this? Instead of 1 and 5, it's negative 1 and 5. Then what?
Oh, absolute value.
Keep going.
You add the absolute value.
And then what?
And you get patterns, and then you divide by 2.
And that says how far to get to the middle point. If you know where 1 is, you can just either subtract from that point or add to that point. So let's say we have them here. Okay. Minimum of 10 again, let's put negative 10. So I know that somewhere in between here, there's my vertex. I know it's at something, negative 10. All right, I want you to find what is, so let's see if it goes like this. That's pretty good. What is my axis of symmetry? Because I know my vertex is going to be there at negative 10 for y. So let's see if that idea worked, right? Take the absolute value of each one, find the difference. It doesn't what? Doesn't work? No? Angie, what do you think? 2. 2 is right in the middle. Okay, let's see if we can work out how we got 2. I agree. It's 2. So you're basically, here's the deal. What is the absolute value? It's the distance from 0. Okay, so if we take the absolute value of negative 1, right, we're finding that distance from 0, and it's 1. We take the absolute value of 5, it's the distance from 0, it's that. So if we add those together and divide by 2, we find where we're going to be in the middle. Okay, so let's see. We have, we're going to end up negative 1 absolute value plus 5 absolute value. Divide by 2. We're going to get 6 divided by 2. We're going to get 3 units. So from each point, here it's going to be 3 units in. Here it's going to be 3 units in. And you can just count from either direction to find the middle point. Yeah, that's all we have to do. So finding it is just going to be in the middle there. We have 2 problems to do like this, so I don't want to spend too much time on it. But thumbs up, sideways, down. Today's been longer than expected. I guess it has. Okay. That ain't bad. That ain't bad. We got most of it. Let's work together in pairs on this. Use Desmos. You're using Desmos for all of them. You got to show where it's increasing, decreasing. You got to show if it's a minimum or maximum. All that fun stuff. All right. It's in the workbook 1 through 6. Graph everything. Book 1 through 4. Graph everything. The book's already on Edmodo. I put it up. All right. Don't forget to subscribe. No one's listening to that anymore.